Hey guys, welcome. My name is David and I do competitive coding and LeetCode questions here on YouTube. And today's question that we're going to go over is called most common word. This question is used a lot by Amazon and other companies for online assessment portion, which is usually the first step in most interview processes to kind of determine whether or not you're going to be a good fit and you have some basic knowledge of data structures and algorithms. So let's dive on into this question here, which reads, given a string called paragraph and or a string array of banned words called banned, return the most frequent word that is not banned. It is guaranteed that at least one word is not banned, and the answer is unique. The words in the paragraph are not case sensitive, and we should return the answer in lowercase. So that means that we are going to want to try and take this in some nature and this paragraph in some nature and split it up into different sections, um, and basically take account of all of those words. And from there, we can just take whatever the most common one is and return that. So let's go ahead and dive on in. Now, something to note here is, like they show here, in this case, Bob hit a ball, the ball flew far after it was hit. Um, the most common word here is ball, and we have ball here twice. Once is a all caps and once lowercase, but it also has this special character here. So that is a possibility. If we look down at the constraints, we can see that, there are going to be symbols in this, and we can go ahead and ignore those symbols. They do not matter. We're just trying to figure out what the most common word is. So let's first start out by handling the case and sensitivity. So if we take paragraph and we just set it equal to paragraph dot to lowercase, we will then just completely erase all case sensitivity, right? So now everything's in lowercase. And then we want to handle the banned word. So there's a couple of ways that we can go about doing this. The best one's probably just to throw it all into a hash set, just to compare in constant time whether or not the words when we go through the paragraph exist inside the banned words. Another option that we could do is since we're going to be using a hash map to count the words, um, we could put the banned words inside a hash map and set their value to be negative. And then when we go to compare the words, we can check to see whether or not the words get or default is greater than or equal to 0. That would tell us whether or not the word is um, banned. But it does make our logic a little bit more convoluted, whereas using a hash set that just contains all of the banned words and has constant lookup time is just a little bit more obvious what's going on. So I just like going with that just because it's a bit more straightforward. And if an interviewer were to ask us some questions, it'd just make a little bit more sense. Um, so let's go ahead and create that hash set really quick. So it's going to be a hash set of strings. We'll call it, I don't know, ban, which will be a new hash set of type string. And then we can go ahead and say arrays dot as list of banned, and that'll go ahead and just create it all and default it. So next, like I said, we're going to need a hash map as well, and this is going to map string to integer, and we can call this counts. Um, and that'll just be a new hash set or hash map, sorry. Um, and then the last thing that we're going to need is we're going to need a string. So we're going to need a string that's called answer. And then I also, to do this in one single pass, I'm also going to initialize a variable called max that will hold the maximum value as well. So we'll go ahead and create that. So we have our string that is ants, which will just default to an empty string, and then we'll also have an int called count, or sorry, not count, we'll call it max, which will start out as 0, as we don't have any words that are, well, maxed, right? So next, what we're going to need to do is we're going to need to split up the words and just go through them by one. So what we can do is we can say for string word in paragraph, and then we want to split this, and we're going to want to split this by just the words no uh, with no special characters. So we can do this with this regex capital W plus, and you can look these up online. Java has this whole little regex patterns. So if you want to look those up and find the best way to do that, you can. An alternative would be to replace everything that is not a letter with a blank, or with basically just remove all special characters and then split on space. That would also work. Um, but either way, you'll have to use some type of regex to kind of remove out any type of special characters and split the words apart. Uh, so we're just going to do it this way. It's my preferred. Um, yeah. So now we have every word, and they're all in lowercase. So we just want to iterate through these words and to check whether or not this word is the current maximum seen and whether or not it is a part of the ban. So the first thing that we'll do is we'll say if ban.contains word, we can just go ahead and continue because it does not matter to us. Man, typing's hard. Next, we are going to say, okay, so it's not a banned word, so what is the count? So we can go ahead and get the count by saying int count equals counts.get or default. And then we'll pass in the word and 0. So if the word's not inside the hash map, we'll go ahead and just return 0. Otherwise, we'll get the actual word, and we're going to actually want to +1 this because we've seen it once, right? So that is the current count. It's either 1 or 1 plus whatever whatever we had previously, right? So then if this count is greater than max, we can set the answer equal to the word, and then no matter what, we will go ahead. We also want to set max equal to the count because we've now found the new max. Then from there, we can go ahead and put inside counts dot to put the word and the new count that we got that's auto been incremented. And once this is all done, we can just return the ants. So let's go ahead and run this and see what happens here. Awesome. And then we can also run on some special test case. Let's just go with something like, I don't know, maybe a question mark, and say sure, it can be the banned word here. In this case, we would expect A to be the answer, and so this is the output, this is the expected. As we can see, we passed that. Let's go ahead and submit, and what do we get? Awesome, we get the right answer here. And as you can see, our runtime was 11 seconds or 11 milliseconds, and that was faster than 75%. So as for our time complexity and space complexity, so our space is going to be just the size of all of the words in this, including from paragraph to band, and then um, our time complexity is going to be O of n because we're iterating over every single word as well as every single band word. Um, our lookup times here are going to be in constant time. Again, we could cut down on these two initializations. Hash maps and sets are very expensive operations to create. Um, so it would technically be a bit more space efficient to just use a single map and throw everything in with positive and negatives. However, it makes it just a little bit more complicated when you're looking at the logic behind it. But again, it is a little bit more space efficient. So that is kind of your choice there. It's got a little bit of trade-offs. So either way, that is our time and space complexity here. and that is most common words. Thank you for stopping by and watching. If you like the video, please leave me a thumbs up and subscribe. And if you have any recommendations for next videos, just go ahead and leave a comment below and I'll see what I can do. Thanks.